Hello guys, welcome back. In this video, we are after learning interpolation in our previous video. In this video, we are going to solve some objective type questions. So here we are with some objective exercise for interpolation, part 1. Then we will have objective exercise part 2. So let's proceed with the exercise. So the first question we have is, which of the following interpolation technique is used to find the value of a function at a point lying outside the known data points? A. Newton forward interpolation. B. Newton backward interpolation. C. Newton divided different interpolation. Or D. Lagrange interpolation. As we have already learned in our previous video, which technique can be used to find a point lying outside the known data points? That is Newton's divided difference interpolation, right? From in for inside, we generally use Newton forward interpolation and Newton backward interpolation, and Lagrange interpolation too. For the points that are outside the given range will be done by Newton divided difference interpolation. So the answer is C, Newton divided difference interpolation. Okay, now let's jump on to the next question. So next question is, which of the following is not a disadvantage of Newton forward difference interpolation? So the our options are: A, it cannot be used for large values of n. B, it requires equally spaced data points. C, it is sensitive to errors in the data points. Or D, it is computationally intensive. So these are general, basically, for Newton forward difference interpolation. These are its general properties. So among its property, what serves as a disadvantage for this type of interpolation? So the disadvantage here is D, that is computationally intensive, because it cannot be used for large values of n. Then we have another interpolation technique that can require for equally spaced data points. That is also, we can easily calculate, and most of the time we can get the equally spaced data points. It is its general property. The property which is actually disadvantageous is that it is computationally intensive, so it will take more complex computations, right? So our answer is C. Wait a minute. So our answer is D. It is computationally intensive, right? Now let's jump on to the next question. So next question we have is, which of the following interpolation technique is used to find the values of a function at a point lying before the known data points? Okay, so after the known data points, we use Newton forward. Before the known data point, it is Newton backward. We already discussed these things in our previous video. So the answer is B, Newton backward interpolation. My God, Newton backward interpolation. B, Newton backward interpolation. Now, let's jump on to the next question. Which of the following interpolation uh, technique uses polynomial of a degree n minus 1 to interpolate the n data points? Right? So our options are: A, Newton forward difference interpolation; B, Newton backward difference interpolation; C, Newton divided difference interpolation; and D, Lagrange interpolation. So the answer is B, Lagrange interpolation, because it creates a polynomial that will pass through all the data points. So that is basic functionality of the Lagrange interpolation. So the answer is B, uh, Lagrange interpolation. Okay. Now our next question is, which of the following is not a disadvantage of Newton backward interpolation? So our options are: A, it requires equally spaced data points; B, it is sensitive to errors in the data point; C, it cannot be used for large values of n; or D, it is computationally intensive. It is a similar question, but here it is about Newton backward interpolation. So for backward interpolation, the answer is C. It cannot be used for larger values of n. So if the n is very large, then it is a disadvantage. but it requires the equally space. It is not much of a disadvantage, and it is sensitive to the errors of the data points. It is also not much of a disadvantage, and it is computationally intensive. Is also not because it is mainly used for to find the data point before the known data point, right? So uh, we can also use forward difference interpolation for the same thing if it is within the range which has been given. But for Newton backward interpolation, in that case, the more advantage disadvantageous situation is that it cannot be used for larger values of n. Okay, so the answer is C. It cannot be used for large values of n. Now let's jump on to the another question. Which of the following interpolation technique is used to find the values of a function at a point lying between the known data points, right? So our options are A. Newton forward interpolation, B. Newton backward interpolation, C. Newton divided difference interpolation, or D. Lagrange interpolation. So our answer is D. Lagrange interpolation, because if we want to find the values of a function at a points lying between the known data points, which it can be Lagrange interpolation. It not necessarily has to be if fixed with fixed equally spaced, but in Lagrange interpolation we can easily find the values of a function at a point lying between the known data points, right? So answer is D, Lagrange interpolation. Let's jump on to the next question. Next question is, which of the following is the correct formula for Newton divided difference interpolation? The, the options are A, f of x is equal to f of xo plus f of xo, comma, x plus f of xo, x only, that is x0, so x or x0, comma, x1, comma, x2, bracket x minus x1, and so on. Or B, f of x equal to f of xn plus f of xn minus 1, comma, f of xn plus f of xn minus 2, xn minus 1, xn in the bracket x minus xn minus 1 plus, and so on. Similarly, we have other options C and D. So which option correctly represents the formula of the divided difference interpolation? It is clear from the formula that A is the answer. Sorry. Huh. No. A is the answer. F of x is equal to f of x0 plus f of x0, comma, f of x1 plus f of x0, comma, x1, comma, x2, x minus x1, and so on. We have already discussed these things in the previous video. So if you are not able to comprehend what I'm trying to explain, so please do watch a previous video on interpolation, which the link has been given in the description box below. So the next question is question number 8. Which of the following is the correct formula for the first divided difference in the Newton divided difference interpolation? A, f of xi is equal to f of xi. B, f of xi is equal to f of xi plus 1 minus f of xi. C, f of xi is equal to f of xi plus 1 minus f of xi divided by xi plus 1 minus xi. F of xi, or D, f of xi is equal to f of xi minus f of xi minus 1 divided by xi minus xi minus 1. So the answer for this question, it is the question for divided difference interpolation. We have already had a look over the uh, difference table for divided difference interpolation in our earlier video. So the answer is D, f of xi is equal to f of xi minus f of xi minus 1 divided by xi minus xi minus 1. Okay, so let's jump on to the next question. Uh, what is the basic difference between Newton forward and backward interpolation method? So Newton forward interpolation method uses forward differences, whereas backward interpolation uses backward differences. Newton forward interpolation uses backward differences, whereas backward interpolation uses forward differences. Both the Newton forward and backward interpolation method uses same formula for interpolation, or D, none of the above. So as we can see here, the Newton forward interpolation uses forward difference operator, and backward interpolation uses backward difference operator. And we have already seen their formulas and their differences table. So the correct answer is A. Neutral forward difference interpolation uses forward differences, whereas backward difference interpolation uses backward differences. Right? Yeah. So answer is A. Newton forward difference interpolation uses forward differences, whereas backward difference interpolation uses backward differences. Coming on to the next question number 10. In the Newton divided difference formula, what is the purpose of using high order differences? A. To increase the accuracy of the interpolation. B. To decrease the accuracy of interpolation. C. To make the interpolation faster. Or D. None of the above. So the main purpose for Newton divided difference formula, why we use Newton divided difference, is obviously to increase the accuracy of the interpolation, not to decrease. If it is decreased, then why do we use that formula, right? For doing so. And to make the interpolation faster, no, it is not that. It's just totally, the main purpose is to increase the accuracy of interpolation. So yeah, our answer is A, to increase the accuracy of interpolation. Okay, let's jump on to the next question. Uh, Question number 11. Which of the following interpolation method is not based on polynomial approximation? A. Newton forward difference. B. Newton backward difference. C. Lagrange interpolation. Or D. Divided difference interpolation. So the correct answer is D. Divided difference interpolation. Because Lagrange, Newton forward and Newton backward, they are all use polynomial approximation for finding the derivative of a function. Okay, so so the answer is D. Divided difference interpolation. Now let's jump on to the next question. So next question number 12 is, what is the difference between Newton divided difference interpolation and Lagrange interpolation? A. Newton divided difference interpolation uses forward differences, whereas Lagrange interpolation uses backward differences. Newton's divided difference interpolation uses backward differences, whereas Lagrange interpolation uses forward differences. C. Newton divided difference interpolation uses divided differences, whereas Lagrange interpolation uses polynomial interpolation. Or D. None of the above. So we have to find the difference between Lagrange and divided. So the main difference is that divided difference interpolation use the divided difference operator, whereas Lagrange interpolation uses polynomial interpolation. As easy as that. So the answer is C. Newton divided difference interpolation uses divided differences, whereas Lagrange interpolation uses polynomial interpolation. Okay. So our answer is C. Newton divided difference interpolation uses divided differences, whereas Lagrange interpolation uses polynomial interpolation. Right? So let's jump on to the next question. Which of the following interpolation method is more suitable for unevenly spaced data points? A. Newton forward interpolation. B. Newton backward interpolation. C. Difference interpolation. Or D. Lagrange interpolation. So the answer is D. Lagrange interpolation. Why? The answer is D. Lagrange interpolation. For unevenly spaced data points, I have already discussed in the video, Lagrange interpolation is used for Newton forward and backward. The data points should be equally sized. It is the property. Without, if it is not equally spaced, then it won't work. So for that reason, Lagrange interpolation is more used because it is more suitable for unequally spaced data. So answer is D, Lagrange interpolation. Now let's go further to the next question. And the next question is, we are jumping on to this question. Next question, which says that which of the following interpolation method is known as the method of finite differences? Okay, so there's a name which method is also called as this. I have named Priyanshi. I have also called Rashi. So what is other name for Priyanshi? That is Rashi. I don't know why I'm blabbering this. So coming on to the options: A. Newton forward interpolation. B. Newton backward interpolation, C. Divided difference interpolation, or D. Lagrange interpolation. So the answer is C. Divided difference or interpolation. Divided difference interpolation is also known as the method of finite differences. In this, we uses divided differences for interpolating the function and for finding the value, uh, for finding the for finding the value of a point x within or outside the, find the value of x and determining the value of a function with a given data point, right? So the answer is D, divided difference interpolation. Now the next question is, what is the order of polynomial used in the forward interpolation? The polynomial we create in the Newton forward difference interpolation, what will be its order? Okay, so the order in Newton's forward difference interpolation is d n minus 1. Okay, इसलिए कहते हैं, just check out the previous video. Everything is explained and everything is sorted, right? So what is order of the polynomial? What is the Newton's forward interpolation? Newton's forward interpolation is used to find the data point after the known data point, used to find the value of function at a data point after the given data point. Okay, so for this, the Newton's forward difference, the polynomial used in this method has the order n minus 1. Okay, so answer is b n minus 1. Now let's jump on to the next question. Next question is, which of the following interpolation method uses the concept of interpolation error? A. Newton forward interpolation, B. Newton backward interpolation, C. Lagrange interpolation, or D. None of the above. So the answer is, concept of interpolation error is mostly u- most important concept that is used or coined for Lagrange interpolation. So the answer is C, Lagrange interpolation. Right? Now let's jump on to the next question. Next question is question number 17. Which of the following interpolation methods can be used to interpolate the function with complex values? Now that complexity comes. So A. Newton forward interpolation, B. Newton backward interpolation, C. Divided difference interpolation, or D. Lagrange interpolation. So the answer is D, Lagrange interpolation. In Lagrange interpolation, we can interpolate the function with the complex values. Complex values include the imaginary value I. So example of a complex value can be, for example, A. Let's take A. A is equal to 2 plus 3i, where I is basically under root of minus 1. That is an imaginary number. Okay, so we are not going in deeper into the complex numbers and its grammar and all of that. Let's jump on to the next question. So the answer of this question is D, Lagrange interpolation. Now let's jump on to the next question. What is the drawback of higher order differences in the Newton divided difference interpolation? A. Higher computational complexity. B. Decreased accuracy. C. Higher degree of polynomial approximation. Or D. None of the above. So the answer is, what is the drawback of using higher order differences in the Newton divided difference interpolation? So the drawback here is obviously higher computational complexity. Higher the complexity, more computational analysis will be done. It will also slow down the speed and efficiency of the system. So yeah, a higher computational complexity. Coming on to the next question. What is the main difference between Newton-Cotes formula and Gaussian quadrature formulas for numerical integration? Interesting. A Newton-Cotes formula use equidistant points, whereas Gaussian quadrature formula use non-equidistant point. A, that is A. B. Newton-Cotes formula use non-equidistant points, whereas Gaussian quadrature formula use equidistant points. C. Both Newton-Cotes and Gauss quadrature formula use same type of points for integration. Or D. None of the above. So here the answer is A. Newton-Cotes formula always uses equidistant points, whereas Gauss quadrature formula uses non-equidistant points. Okay, so answer is A. Newton-Cotes formula uses equidistant points, whereas Newton Gaussian quadrature formula uses non-equidistant point. Please remember it. Question number, don't remember it. It will not just, I'm not telling you to just rectify all the things written नहीं है इतना सारा, right? But just understand the basic concept, right? These questions are very easy, and these questions are created to have a uh, basic understanding of interpolation and numerical integration methods, to have our basic strongs. That's why we have created simple exercise and we are solving these exercises to have a basic strongs, to make strong base. It is a kind of tricky also, but it's okay. Which of the following is example of numerical integration method? A. Simpson's 1 by 3 rule. B. Simpson's 3 by 8 rule. C. Trapezoidal rule. Or D. All of the above. So, guess what? You can guess this answer. You can pause the video and guess this answer. It is so easy. Which of the following is an example of numerical integration method? So the example of numerical integration method are all of the above. Simpson 1 by 3, Simpson 3 by 8, trapezoidal rule, all of the above are integration methods. Before that interpolating, we are basically finding the derivative, and these Simpson rule, trapezoidal rule, cos quadrature, Newton cos are all for the integration purposes, right? So here we have done with the first part of our video. Uh, for there is also one more second part. So thanks. That's all for today. Thank you. Thank you so much.